Good morning everyone, my name is Ratna Novitasari and I'm a student of Industrial Engineering in 11 Maret University. I'm going to talk about my research which written with Professor Cucuk Rosyidi and Mrs. Azizah Aisyati. The title of the research is a cut-off grade optimization model in multi-product open pit mining considering reclamation and valuable waste materials. This presentation will be in 4 parts. First is introduction, second is model development, third is numerical example, and fourth is conclusion. The first is introduction. As we can see at the news on the slide, the demand and extraction activities of the natural research are increased. One of them is the need for the minerals such as iron and copper to satisfy the demand of industry as well as infrastructure. One of the methods that used to get the mineral is open pit mining. But the mining operations are inseparable from the environmental impact, where according to a recent study by Osanlo in 2012, the waste generated by the mining activities in 2030 will reach 56 billion tons. So, the mining industry have to take the responsibility to revaluing the waste materials. Besides the waste, mining operation also has environmental problems from the mine site and tailing dams. Reclamation is needed in this case and needs to be included in the cut-off grade calculation. In this research, we consider a mining company which produces multi-products, namely concentrate, sizing, and pellet to calculate the optimum cut-off grade. This is the position of this research. We base our research on 3 previous models of Lane, Narve and Osanlo, and Mohammadi. Lane model is the basic algorithm for calculating the cut-off grade. Narve and Osanlo developed model by adding the environmental impact from the mining to calculate the cut-off grade. In other side, Mohammadi developed cut-off grade model for open pit mining with multi-products. Here are some notation of the model, such as capacity of each process, price, and cost of production. The objective function of the model in this research is to maximize the net present value, with 3 main assumptions. The first is maximum capacity of the concentrate plant is 12 million tons. Sizing plant is 1 million tons and pelletizing plant is 4.2 million tons. The second is the minimum grade for sending material from the concentrate plant to the sizing unit is 57%, and all of the final product's price is constant at each year. The model consists of the quantity of the ore that must be sent off each plant. There is QGR for the sizing plant, QCon for the concentrate plant, QP for the pelletizing plant, and QR is the total of sellable products. We can see here the revenue formulation, which is from the selling products for concentrate, sizing, and pellet. The other revenue is from the reclamation and the revaluing the waste materials, as we can see in the equation on the slide. The model also consists the cost function related to mining, concentrating, pelletizing, sizing, fixed cost, reclamation, and revaluing waste materials. This is the formula of net cash flow equation based on the revenue and the relevant costs. The constraint of this model is the capacity of each process and the coefficient of the waste, such as the material mined or KM must be lower than the mining capacity of M. To determine the cut-off grade, we have to derive the function of NCF or net cash flow for each process. This is the value of cut-off grade due to the limitation in the mining capacity, concentrate capacity, and pelletizing capacity. After limiting, the next step is to balancing the cut-off grade to get the optimum cut-off grade. There is some rules for the balancing process, as you can see at the slide. And after the model is developed, we move to the numerical example. At this step, we use data from the research of Nare and Osanlu. We can see the grade distribution and the data set of economic variables in Table 2 and Table 3. In the numerical example, we calculate two things. The first is the optimum cut-off grade and NPV calculation without reclamation and revaluing waste. The result can see in Table 4 and Table 5. Second is the optimum cut-off grade and NPV calculation with reclamation and revaluing waste. The results are shown in Table 6 and Table 7. In the second scenario with the model development, the cut-off grade reduced from 58.76% to 37.71% at the 5th year. The total NPV with a discount rate 21% is obtained to be million real 81,474.88. It means there is 12% improvement of NPV using the model for multi-product with considering reclamation and revaluing waste materials. For the conclusion, in this study, we demonstrate the relationship between economic and environmental factors in terms of reclamation and revaluing of waste materials. We also considered the multi-product to calculate the optimum cut-off grade. In this model, we consider the reclamation cost because mining industry have responsibilities to maintain the environmental impact from their mining activities. By using the developed model in this paper, the mining industry can get maximum NPV while in the same time maintain the environmental sustainability. This model is also simple and easy to be applied. For the future research, this cut-off grade model can be developed further by adding the price uncertainty for the selling products to get a closer real value of the profit and NPV. This is the end of this presentation, and thank you for your attention.